So Stata usually comes in this format. I have the software open right here. I have a different set of colors, but it's exactly the same software that you will have in your computers. That doesn't matter. Stata has 4 different windows or 4 different panels that you're going to see when you just enter into the program. This first window over here that says variables shows you exactly that. Once you open a data set, it's going to show you the list of variables that are available in the data set. So for example, if I open now this data set here, you see we have here all these variables that are included in the data. So for example, I have a variable that is called household ID, region, area, and so on. Now, this window or this panel over here also shows you the label of the variable. Variables have the option, not always, but sometimes they do have a label or an explanation or some type of comment that was added to it when the data set was being created. So for example, and it's usually very useful to understand what the variable is. Imagine, for example, if you need to work with this variable here, it's called V2Q7. You don't have any clue about what that variable might mean. But if you go to the label here, it means external walls. So you know that it's a variable that has something to do with the external walls. It's going to be the quality or the material of the external walls in particular. But you already have some kind of idea of what you're talking about. This second panel right here, the one on the bottom, command, is where you're going to type. This is where you're going to ask Stata to perform certain tasks. I want to go through the commands in a second, but just to show you how to do it, you will put yourself you will click in that window and type something that you want Stata to do. For example, describe. The command describe is basically describing the data set. So we have information here shown in this panel at the top. Right? So I write it right here, and Stata is going to show me the results of what I'm asking the program to do right here in this window or this panel at the top. And as you can see here, in this last panel over here, Stata is going to be listing all the different things that I asked the program to do. So the first thing was to open the data set. And the command that I used to open a data set is use. So that's why it says use over there. And the second command is the one that I just wrote, the one that I just typed, describe. So basically that's, and I can also double click here. If I wanted the Stata to do again, to repeat an action, I could double click here and Stata would do it again. Okay? Good. Now, this is the general way that this is what you're going to look at when you're working on Stata. So this is how we're going to work. Now, Stata, imagine that you're creating an MPI. Imagine that something that you're actually going to start doing tomorrow, right? That you have to put together many indicators, 10, 15, 20 indicators, weights. You have to ask Stata to compute a lot of things, the head counts, the unsensor head counts and the sensor head counts, H, A, M0, the contribution, to make graphs and tables. Imagine that you have to remember all those commands by heart. And then every time you open the data set, imagine that you say, no, actually, rather than considering school attendance for children between 8 and 15, I want to do it for children 8-14. And so you need to type again all the commands or the lines of requests that you made to the program all over again. It will take forever if every time that we need to recompute something, we needed to write down all the commands again. So Stata offers us the option to create a document in which we can store a list of commands, a whole program of commands that we are asking Stata to perform. In the same way that documents in Word are stored in a .doc format, documents in Stata are created with a .do format, and they are called do files because they are asking Stata to do stuff, basically. So that's what we are going to do. We're going to create do files. We're going to create a whole list of requests or a whole list of commands that Stata is going to be running all together. So then if I want to recompute, I can do it just by clicking on the do file. If I want to change something on the do file, I can change a particular parameter, I can change a particular line without having to change the other 1,000 lines that we have. In our do files, for example, for a country's results for the global MPI, we have more or less 3,000 lines. Imagine if we had to write those down every time we are recomputing something. It would be crazy. So the do files are actually a very useful tool, and that's what you are going to be doing. We are actually I'm going to show you now one do file that we've already shared with you, that it contains the most basic commands that we're going to be using on Stata. And then we're going to share with you in the next few days another do file. We're going to start by sharing you the first part of the do file, and then a second part and a third part, in which you're actually going to already be given the commands to create and compute the MPI. But you're going to need to adapt it to the particular example that you are computing. This is a very basic one, and you're going to need to adjust it for your particular case. So if you want to create a do file, you have to go here to this icon here. Can you see, or is the font too small? Can everybody see? Yeah? Okay, so that little icon over there, it's representing a do file. So if you click on it, this is going to be your blank sheet where you can start typing everything you want Stata to do. So I could write here, for example, describe, and I could write code book. I'm going to explain what these commands are in a second, but just to give you an example. I could write here all the commands. Imagine that I want Stata to do these three commands. And then I come to the very end here when I'm asking Stata to run it. You see, it says execute do. So I click here and I go back to the main window, and Stata is going to run everything I ask it to do. Okay, I have the 3 lines of command already run for me. First, the describe command. Then the second command that I asked, which was codebook region, and the third one, tabulate region. Okay, so if I want to change something, imagine that now instead of region, I want to tabulate a different variable, I can just come to the do file and change it here without having to actually write down everything again. So this is what you're going to be doing once you are creating your own MPI. Now, in this 2-pager that we share with you, it already has a list of the main commands that you're going to be using on Stata. So it tells you how to open the data set, how to import data from an Excel file, how to add weights, how to browse, how to look at particular variables. Everything is there, but we're going to go one by one on the do file. But this you already have as a very short and very brief guide on how to use Stata. So let me just go to the do file. You also should have it there. I'm going to increase the font here. Can everybody see? Okay, the font? Yes. Okay. So something to consider is that sometimes, and something that I was mentioning before, is that because we want to be very transparent and very clear, and we want our files to be able to be used by other people that might come to our positions after us, after we leave, we always add to our files many comments. And that includes our do files. Usually when we compute the global MPI, or when we are working in other paper, and this is something that I always do with my research independently of where I've been working or for my studies and so on, is that I add a lot of comments in my do files so that I can go back to those computations at any point in time and understand what I was doing and why I was doing it, and why did I choose to use particular lines and particular commands and particular filters. I always like to keep my do files with a lot of comments, and also because sometimes you are sharing it with people. And so if you get a do file, if you get a list of commands and you don't really get an explanation, you get completely lost. It's difficult to follow someone else's mindset when they are creating a do file. So how do you make comments in a do file without Stata finding an error? Like, for example, if I start typing in a do file, or if I start typing a command here telling, now I want to compute the mean age for women, and I just put that in my do file, in this document that I'm starting to write, no, not that, this one, Stata is going to think that it's a command, and it's going to try to run a command that it's now, and it's going to say, no, there is no such command. It's going to give me an error, right? So for example, here, I put a note here saying to compute, to see regions, whatever. And this is just a comment for me. Now, if I just write to see that I want to see the regions and that I'm trying to see the regions, Stata is going to believe that that line over here, it's a command, that there is a command called to. And so this is what I'm going to get. I'm going to get an error that always appears like this in Stata, telling me unrecognized command to. So I have to do something to let Stata know that that's a comment, that it shouldn't try to run it. And one way to do it is actually to add here an asterisk. So you see that even the color of that line has changed. It's shown in a different color now. It's now a comment. So now if I try to run this do file, Stata will actually do it without giving me any error. It ran it and it's telling me, okay, end of do file. I finished running everything you asked me to. So that's one way you can add comments, adding an asterisk at the beginning, or 2 or 3, as many as you want. So asterisks are always considered as data as showing that there is a comment. Another way is to put 2 diagonal bars. So I could have done something like this instead, putting 2 bars like this. Stata would have also understand that that was a comment, and that's why it's also in a green color in the do file. Well, the colors doesn't matter, because the colors is something that you can choose. You can change, like for example, the background color for my Stata is black, and by default it comes as white. So the colors doesn't matter, but just to bear in mind that it's shown in a different color there, so it's already, you can already see that it's being considered as a comment. And then imagine that you want to put a very long comment, right? Something that is not just a line, that it might take you many lines, right? Because sometimes you really want to put, like, explain the decisions and copy a paragraph that you took from a report. For example, when we are creating the indicators of deprivation in water, we include a comment in our do file explaining which are the criteria, the MDG's criteria of how they select sources or how they identify sources as improved and non-improved. So we have a whole paragraph of the MDG's report right there in the do file. Now, I'm going to have many lines there. One option is that each line could have an asterisk at the beginning or 2 diagonal lines. Or I could do something different. I could start a comment like this with 1 diagonal line, 1 asterisk, then I start writing all the text that I want it to be comment, whatever it is, and I finish the opposite way, an asterisk and a diagonal line. Everything that is between those 2 things is going to be considered a comment, whether it is 1 line, 10 lines, or 200 lines. It doesn't matter. Everything that falls within those characters, it's going to be considered a comment. Sometimes when we are running a do file, imagine we are running some very long do file because we are programming something, we're trying to estimate an MPI or something like that. And sometimes you don't want to run the whole thing. You just want to run maybe the nutrition, the block that has something to do with nutrition. So you can deactivate the rest of the do file by using this. You add this at the very beginning of the part that you don't want to run. And so everything that falls in between, it's going to be considered as comment by Stata. So it's not going to run it. It's going to be deactivated. Okay? So that's something that it's usually quite useful when you're trying to run things. And that's something that I'm using here, and that's why I wanted to explain it. I'm explaining in these lines what each of the codes is doing, and I'm explaining it as comments. So that's why they have this asterisk here to explain what we are doing. Okay, so the first thing that I'm going to do is that, imagine, for example, that you have been working with a data set, like this one here, and you have been creating indicators, and you have been creating new variables and estimating things. If you try to open a new data set after that, Stata is going to tell you, no, you know what, you have unsaved work. You have been creating variables, you have been doing stuff on this data set, but you haven't saved it yet. It's going to warn you, be careful, if you open something new, you're going to lose your work. So how do you tell Stata to kind of force that process? You tell Stata first, okay, I want to clean everything that's open and start from scratch. I want to start with a completely empty Stata. So you do that with this command over here, clear. Oh, that's not what it is. No. Clear. What clear is going to do is to close everything that's open and to erase everything that's in Stata memory. Now, that option all that we add at the end is because in Stata you can also, for example, create matrices and start saving results in matrices, as in tables. So when we add that option all, we're telling Stata, okay, close the data sets, forget everything, forget locals, forget globals, that I'm going to explain what that are, delete all the matrices that we had created, start from scratch, really close everything that was open at the moment. And this line over here is an optional line. You're not going to need to use it all the time. But imagine, for example, that I use this command, for example, that I was using before, describe. With the command, as you can see, with the command describe, as you can see, because the data set has 78 variables, right? It's telling me here that it has 78 variables. I cannot see all the 78 at once. So Stata is showing me the first ones, the ones that fit in this window. If I want to see the rest, I need to click on the spacebar, and it's going to show me more, and it's going to show me more. I need to keep on clicking spacebar. Now, when we are writing a very long do file, and if we have some particular command that is leading us to a situation like this, in which we need to press the spacebar to see more, Stata is actually going to stop. It's going to stay on hold until you go back to the screen and press the spacebar. Now, many times we actually want Stata to just run the whole thing, not to stop waiting for us. So this is what the command set more of is telling Stata, that I don't need to be pressing the spacebar to ask for more, that it should be automatically. So if I write here set more of, and I do the describe again, Stata went all the way to the end. You see, I didn't have to press the spacebar. So that's an optional thing. You might want to have it or not. But usually if you leave something running in your computer, sometimes some do files could take hours. So you leave and you do something else, and then you come back and you see that Stata didn't finish because it was waiting for you to press the space key. So when you are actually running something very long and you don't need to be on the computer, you don't actually need to check all those more options, it's very useful to have that at the beginning of the do file. But it's an optional thing that you can add or not. Now, here what we are telling, we're going to need to, when we are working in a do file, we're going to need to be very precise when telling Stata where are the data sets that we are using placed, and where everything that we are doing needs to be saved. We need to provide Stata with the paths to specify the exact folder in which we are saving everything and in which everything is stored. And that means that sometimes we have a very long path that we need to write every time, right? Imagine, for example, if I have to go to, I don't know, let's see, I'm going to push it. Imagine, for example, that I'm working with Belize, and so it's in this folder over here. Look, it took me 2 lines to write the whole folder. Imagine if every time that I need to tell Stata to go to that folder, I need to type it. It's too long. So I can just tell Stata, okay, from now on, I'm going to be working in this particular folder. This is the folder that you should go to pick all the data, and this is the folder where you should save everything that I'm doing. So I can just do it with this command cd. With cd means change directory. So basically we are specifying the directory, the folder in which we're going to be working. And here you need to put the whole folder, the path to which Stata needs to go. Once you do that, after that, you don't really need to be specifying anymore. You can just say, okay, use this particular data set, but you don't need to tell Stata to go to one particular folder. Stata already knows. because you have specified it here. Now, something that is very useful also when you're working on Stata is to keep record of everything that you are doing. Because sometimes you want to take out the results. There are different ways in which you can take out results from Stata. It might be because you might be creating matrices and then storing all the results in a matrix, but that's something quite complex and we are not actually going to cover here. If you have any doubts, you can ask us, because we do work with matrices, but here we are not actually going to get into that. It's like a particular app, if you want, that Stata has within the software itself. But another way in which you can do it is to actually keep a record, like an archive, of everything that you're doing on Stata, and then you can go back to that archive and find the results. Now, for example, if I was here tabulating, like I did before, tabulate region, I'm going to see all the different regions in this data set. We are using a data set of Bhutan. So here there are the different regions in the country. And for example, I know that there are 717 people that live in this particular region of the country. Now imagine that afterwards, later on, I want to know how many people were living there, to put it in some table, in a graph or something. I would need to tabulate region again if I don't have it in an archive, in a record of what has been done. But another way is to actually tell Stata to keep a record of all these commands that I'm writing in my do file. So that is what I'm doing in these lines over here. Those archives in Stata are called log files because the format, as in Word, the format was doc, and the do files are .do files. The log files have a format of .log. They keep a log, they keep an archive of what you're doing. So here I'm just telling Stata that I'm going to start a log. Here, I'm going to start a log that it's going to be called log_stata. That's the name that I'm giving to the log file. From now on, what I'm doing is going to be saved in a file that is going to be named log_stata. What I'm telling Stata here is that if there's already another file with that name, Stata needs to replace it. If you don't put that option, option, if you don't actually add that at the end, and there is a file, because imagine that you have already run these two files, so you have already created a log file, but now you want to rerun the do file. So Stata is going to tell you, no, watch out, there is already a file with that name. You are going to have an error and Stata is going to stop. So here I'm telling Stata, okay, if there is a file, just replace it. Just save it over it. And this option here that I have in the previous line, it's because sometimes we already are using a log file. Imagine that you were running things from before and you had already opened a log file in which you were saving stuff. So what I'm telling Stata here is close it. That previous log file, I want you to close it to start a new one, to start saving in a new one. So that's what I'm doing in this line. Something that you're going to see is that this is the general structure of commands in Stata. You're going to write first the command, then the variables over which you need to run that command, then all the filters, and at the end you're going to add a comma and options. So the command here is log, is to actually start saving this archive. But this is a different case because it's not run over a variable. Let me find an example. Okay, here. Here, for example, we're going to go through this command in a second, but just to give you an example of the structure. The command is tabstat. The first word is going to be the command, usually. And you see that it has also a particular color. Commands are always with a particular color. Then there are going to be the variables, the var list over which you are running the command. In this case, this command tabstat that we're going to see in a second, it's going to be run over two variables, age and schooling. Some commands allow you to put a whole var list of variables. Some other commands only allow for one variable because they are run over just one. Then I'm going to have the option of adding weights. As many of you know, because you've already worked with surveys, with household surveys or with different types of sampling designs, many times surveys include weights, because one observation is actually representing many observations when we are trying to expand to the total population of the country or the region. So this is the way in which we apply those weights, in which we tell Stata that there are weights in the data set and that it has to use them. This name here is the name of the variable that it's saving those weights. It could be weight or it could be any other name, whatever name it has on the data set. This is how I add the filters. Here I'm telling Stata that I want Stata to run this command over these variables only if age is greater than 17. This is a filter. I don't want it to run it for the whole survey, for the whole sample. Only for those observations that have age greater than 17. And this is how I'm going to write my filters. I'm going to write if and the actual condition that needs to be fulfilled. And then, as I was saying, you add a comma and the different options. So the option here is that I want this to be done by region. So not the aggregate at the national level. I'm not interested in looking at the aggregate estimations for the whole country, but rather for the 33 regions in Bhutan, separately, one by one. So that is the general structure that we are going to find in Stata, that we are going to follow. And then in this particular case that we were looking at, the case of log file, that's why we put this option, comma replace, in this particular way. There are other programs, like in SPSS, many times you have to put the conditions at the beginning, the filters. In Stata, that's not usually the case, but we're going to see that in particular cases you can do it, but it's not generally how you would run the commands line by line, but rather this other format that I was showing you. Okay, now the next thing would be, we have already been given Stata instructions, but kind of like a preamble, right? Close everything that was open so far. Please open an archive, open a log file, because I want to start saving stuff. I have already told Stata which is the folder where I'm going to be working, but I haven't even opened the data set yet. I still have a blank Stata. So this is what I'm doing here. I'm telling Stata that it has to use this survey, that it has to use this particular survey that it's called Sample Bhutan. And again, we have do files, we have log files, and the data sets in Stata, the Stata format is DTA. So this is what we see here. I'm just telling Stata that that's the data set that it's going to open, and you have it as well. Now, the first command that I'm asking Stata to do on the data set is the one that I've been using, to play around.
What's the difference between this clear and clear all on top of?
No, actually, if you already have that clear at the beginning, this clear here is not needed.
Just an option.
It's an option again. What that clear is doing is, again, you're telling Stata that if you had another data set open, it should close it. But that you don't actually need it. It's an option. So, okay, the command here described is the one that I was using before. You've already seen part of what it does. But, not a set more on. But the first things that are shown when you actually run this command, first it tells you the number of observations. We have almost 25,000 in the case of this survey from Bhutan. The number of variables, 78, the size, and it tells you the last time that it was modified. So it starts by giving you a very basic information of the data set. And then you have a whole description with all the variables, the type of variable that they are, if they are numeric, and if they are numeric, how many decimals they have, what type of numerical variable they are, or whether they are string. For example, if you have an address or if you have a name, it's a non-numerical variable. It's going to be a string variable. And then we also have the labels that I was showing you before. So in many cases, you don't have labels. And if you don't have labels, you have to go back to the documentations from the survey, to the questionnaire and to the dictionary that sometimes is available, or to any methodological document. But in this particular, in the data sets that we are going to be sharing with you, labels are always there. Okay. And at the end, it's telling you this final thing that is here. It's telling you that these 25,000 observations that we have here in the data set are not all mixed up. They are sorted by household. So they start from the lowest number in this household ID to the largest. So all the members from the same household are grouped together in the data set, as we have it right now. Now, the data set, at least, it's still kind of something that we are not really looking at yet. We know that it's there, we know we have the variables, but we are not actually looking at the data. It's not as if we were in Excel, that we actually would have the matrix, right? So how do we get to the matrix? Well, we can type browse. We can type browse, or we can go to this option here that says data editor browse. You can either click there or you can type browse, and there you go. Now you actually have the data set in front of you. So we have the household ID, we have the region, we can see the variables for all the 25,000 observations. This is our actual data set. This is our matrix, right? We have, instead of having 5 rows and 4 columns, like in the paper exercise, we now have almost 25,000 rows, because we have 25,000 people, and we're going to have many columns. Many. Right? We have all the information here. In particular, we said we have 78 variables, so we have 78 rows. And we are able to see everything here. Now, if you choose this command, browse, you get to see the data set, but you cannot change anything on it. If you actually want to be able to look at the data set, but also change stuff, instead of using browse, you would use a similar command, edit. That it's also showing you, it's also taking you to the data set, but allowing you to actually get access to the variable. So you see, you double click, and then you can have access to particular cells to change it. So depending on what you want to do, these two commands are similar in the sense that you get access to the data set, but with browse you're not able to touch it. You're not able to change anything at all. Okay. Let me see. Now, another very useful command to understand a little bit what we have, it's a command codebook. And I'm going to show you what it does. Now, codebook, if you type just codebook, Stata is going to do this. It's going to present you a table like this for every single one variable in your data set. So it will be for 78 variables in this case, or for 200 if you have 200 variables. That's why for this example I only wrote codebook male, female, because I only want Stata to show me this for these particular 2 variables. Now, it's going to show me the variable that I'm using, its label. So now I know that female means the number of females in the household. It's letting me know what type of variable it is. It's telling me its range. There are households that have no women at all, and households that have 11. And it's also telling me how many unique values. We have 12. So it means that we have all the options in between 0 and 11. We have households with 0, 1, 2, 3, 4. So we are able to have 12 unique values. It has 0 missing values. That means that all the almost 25,000 observations in the survey they all have information for this variable. There are no missing values at all for this. This is the total number of observations that I have, and there are no missings. And here is giving me even more information. The mean, so on average, there are 3.13 women per household in Bhutan. And it's giving me the standard deviation. And here I have it for percentiles. The average number of women for the lowest 10% in the distribution of number of female is 1. So when I sort households from those that have fewest women, the lowest number of women, to those that have the largest number of women at home, so from 0 women to 11 women at home, I sort them. If I take the first 10% of households, on average they have only 1. If now I take the lowest 25%, they have on average 2 women. If I take half of the distribution, the average is going to be 3. So actually, we're finding that it's very similar to the mean. And then if I take this, the lowest 75, the average is 4. And if I take the lowest 90%, so almost the entire distribution, I get that the average is 5. So that means that there is very little concentration of households that have these very large values. Even if they exist in the survey, there are very few. So this is already giving me a quite good picture of the variable. We are already getting a lot of information with this command, codebook. And that's why it's so useful. Now, if you, for example, do codebook household house ID, you could see that there are 4,899 unique values. This is the total number of households that we have in the survey. This is a very simple way to know how many households do we have. Because we already know the number of people, right? We already knew it. Even if you do describe, it tells you how many observations do you have. But if you want to get the number of households very easily, this is a very simple way. To codebook the household ID, and you'd see how many unique values you have. That's the number of households. So we have nearly 25,000 people living in almost 5,000 households. Okay? Good. Browse, we have already seen. Okay, now imagine, for example, that when you are working with your creating your own MPIs, you are trying to find which are the indicators that are related to water, because you want to have an indicator of water. Now we have 78 variables in this data set. So with this, if we actually do use the command describe, like we were doing before, we can actually take a look at all of them and try to find which one refers to water. Now, that could take some time, especially if we have a lot of variables. The original DHS, for example, have 600, 700 variables. So another way to look for an indicator is actually use the command look for. So you just type look for water, and Stata is going to show you all the variables in your data set that either have water in their name or in their labels. So this is a very simple way of getting information that you might need. So you already know that there's this variable water, which is the main source of water in the household. This one refers to time spent to fetch the water. And then we have these other ones, water and water boiler. This is the original water variable. And this is one that we created. That's why the one that we created is already called water. But then you have already found variables that are related to the indicator that you were trying to create. So that's also a very useful command, especially when we are working with very large data sets that have a lot of information and a lot of variables. So these are commands that are very useful to find indicators or to describe the data set that you have. But you may want to actually start describing the data a bit more. And the first command that we are going to look at now, we've already used actually, which is to tabulate. So we tabulate the region, like we were doing before, and we know we have now the weighted percentage of people that are living in each of the regions of the country. So we can see that there are particular regions that are much more populated, like the capital of the country has over 14% of the population, but there are other regions that have a much lower participation or much lower proportion of the total sample that is living there. Now, this variable, if we describe the variable, we see that actually this is a byte variable. That means that it's a numerical variable. So if we actually are trying to, if we wanted, for example, to tabulate water only for one of these regions, we couldn't put that region has to be equal to Tronxa, because it's actually a numerical variable. That means that there is a number behind these words, the names, and that these names here are just labels. that appear there. So the way in which we tell Stata to actually show you the real value of the categories is by asking Stata to take away these labels. So we add here again an option, so comma and an option, and we type no label all together. And you see now we see the real information. The names of the regions were placed as labels, because if I were given just this table, I would have no idea which region is region 30. So here what I'm saying, what I'm getting is actually, if I need to code something equal to particular regions, I'm going to need to use these numbers. But I also need information of which region corresponds to each number. To keep on going with tabulate, now we're going to add more information here. Let's assume now that we want to see the different values of the variable radio. So we tabulate radio here. And here we already have the two values. Again, we can ask Stata to show it without the labels, so without this yes and no, and actually see the numbers behind this. And so we now know that no corresponds to a 0, and yes, that means if a household has a radio, it's going to have a number 1. And in this particular case, we have information for all the variables, but if we wanted to check whether they are, well, because we have here 24,786, so we have information for all the variables in the sample. But if we wanted to check whether we are having missing values, whether some households haven't replied to the question, we would add at the end the option missing. Okay? In this way, Stata would have here an additional row. Let me see if I find one that has missings. I remember one. Okay. So for example, for this particular variable, we're going to have, again, all the possible categories, but when we add that option missing, Stata is going to add this at the end. A dot, which represents all the observations that don't have information. In this particular case, we have a very large number. We have that 95% of the population of the sample hasn't given information for this particular variable. This is a variable that probably comes after a filter that only some people need to answer, and that's why we have such a large proportion of people. But when you're working with your own data sets, you're going to find that, for example, if you consider how many people have replied about children's vaccinations, you're going to have a very large proportion of missings because there are many households without children under 5. So they're going to have a dot. So the proportions change a lot. Imagine if we have 95% of the sample with a missing, if we're not adding them into our proportions, by default Stata doesn't. So if we take this out, we're going to distribute that 100% among these other categories, right? So they are going to add up to 100% without considering all the missing values. And that's why it's important to always add the option of missing, because it actually corrects the proportions, because we might be misguided when we think that, okay, maybe this category represents 1.02. No, it actually might represent much less, and by adding the option of missing, we saw that it represented much less. It was 0.05% when we actually take into consideration this. So it's important at least to bear in mind, of course, that when you're talking about children's vaccination, for example, some things you want to estimate directly on the, for the applicable population and not for all. So you want to concentrate only on those that have real values. You want to keep out those households that don't have information because they didn't have children. But in any case, it's informative to actually do this, to have an idea of what type of variable we're talking about and what's the population that has actually answered that question. So it's another option. It comes at the end, and it's basically just comma missing. And you can accumulate. You can write here missing and no label and many other options. You can write many options after the comma, depending on what you're trying to do. Okay, now imagine that we don't only want to tabulate radio, but you want to know what's the proportion of people that have radio that also have television. You want to see if there's an overlap. Or for example, imagine that you have an MPI and you have the proportion of people that are multidimensionally poor, and you have a measure of income poverty, and you want to see how many of the MPI poor are also income poor. So what you want to do is to cross those variables. You want to cross two different indicators. So in that case, you can also use tabulate. Tabulate allows you to add a second variable, and that's what we are doing here. We are tabulating both radio and television with the weights, but we see these numbers are a little difficult to interpret because we have them expanded. So we know that out of the total population now, because we have expanded to population using weights, we now are talking about in million terms, and it's not that easy to understand. So you can add even more options here to convert this into to show percentages rather than frequencies. And this is one of the options. You just add here as an option that you don't want to see the frequencies. So when you tell Stata, don't show me the frequencies, Stata is going to show you the percentage. And that this option cell here, what it's doing is that all these numbers inside the matrix are going to add up to 100. So you know that out of the total sample, well, we're using weights, so out of the population, 25.7%, 24.7% don't have either TV or radio. 24.8 have both. And then we have these groups here that have one or the other. And this adds up to the total population, to 100%. Now you might also want to know what's the proportion of people that have radio that also have television. You might want to know a different number. And in that case, instead of writing cell here, you can write row. So the 100% is going to be add up for each row. So look at the difference between these two. Now we're saying that out of the people that don't have radio, right? So if I only look at those that have answered that they don't have access to radio, 68% also don't have a TV. But 31% of them, they do have access to the TV. So both things are possible, and it depends on what type of a statistic you're trying to get. You just need to add this, that's why this option exists. First you ask to not be shown frequencies, but rather the percentages, and then you add either row or cell, depending on how you want to add up. Yes? Yes. Imagine that now you want to cross two indicators. You want to check the proportion of households without access to, you want to see the access to radio and the access to TV in households. So the first thing that we did in the table at the top here is that we tabulate both these indicators, and Stata show us the frequencies, the expanded frequencies when using weights. So we know that over 6 million people in the country don't have access to either, that another 6 million people have access to both, that almost 3 million have access to TV but they don't have access to radio, and around 10 million have access to radio but they don't have access to TV. Now these are numbers and they can be a little hard sometimes sometimes we are more interested in percentages rather than in numbers. So we ask Stata to show us percentages, to drop the frequencies and just show the percentages. And that's the option of no frequency here. We are telling Stata that we want percentages, not the frequency. Now, when we tell that to Stata, we need to also let the program know how we want these percentages to be computed. So in this first option, by adding this option cell here, what Stata is going to do is that all the numbers that are here, these 4 numbers inside the table, are going to add up to 100. So I know that out of the total population, 39% have access to radio but not to TV, 25% don't have access to any. Another 25 have access to both, and 11.3 have access to TV but not to radio. So those are the percentages, that the direct percentages out of the total population. Now, you might be interested in another statistic, another descriptive statistic. You might be interested in knowing out of a particular group of people. So, of those households that are, or of those individuals that are already deprived in access to radio, those that already have no access to radio, how many of them are also deprived in access to TV? You might want to see the overlap of those. And so that's what you're doing here. You're telling Stata that rather than showing you 100% when you add up these 4 cells, that you want each row to add up to 100. And that's why you change the option here to row. And so you see, okay, out of the people that don't have access to radio, what's the proportion without access to TV? And that's 68.62. And then out of the people that do have access to TV, to radio, how many don't have access to TV? And that's 61.33. So basically that's what we're doing. I mean, it's a very similar type of information, but we are just changing how we read it. Any other question?
I have a question. When there is a missing value, for example, not all of them actually wrote down whether they do have a radio or...
Yeah, you would have here another row for missing,
okay,
and another column for missing here.
okay,
So in that case, what you would find is that you could have people that have information for one indicator, so they might be in the yes or no of radio, but appear here in the dot
okay,
for TV, because they have TV missing.
okay,
Or they might have information for TV, but no information for radio, so they would be here in the row for dot. Or they might be missing both, so they would be in the intersection of dot and dot.
okay, you can create either way.
Yes, so basically, because we have added the option missing here,
Yeah.
if any of these indicators had missings, we would have been seeing them here. State is not showing them because this variable have information for all the observations. Okay. Now, imagine that now we are going to change, we want to add a third variable. We are getting ambitious and we want to keep adding more variables and crossing more stuff. So now we're going to use a different command because we are adding a third variable, so we need to use a different command, which is table. It's similar, but it's not tabulate anymore, it's table. So we're going to be using 3 variables now. Schooling, which refers to the number of years that have been completed of school, gender, and the area, urban or rural area. So now we see these are again labels. This is a numerical variable, but we are showing now the labels so that we know what each number means, right? So here we know for each for each value of years of schooling, we are showing urban and rural, and we're showing female and male separately. So we can get even deeper into the information. And again, this is important to compare groups, to be able to compare by area and to be able to compare by gender. It's important to bear in mind that the order of how you put these indicators is going to change how they appear in the table, right? So the first variable is the one that is going to appear here, going down. And then the second variable, as you can see, is going to be the one that comes here. The last one is going to be the one that is breaking here the table. So if you, rather than having urban and rural, you wanted to have just women and compare women between areas, and men and compare men between areas, you would have to put it the other way around. So you would have first area, and sex would come at the end. It's still going to be the same, you're going to get the same numbers, but it depends on what you're trying to compare. Okay? And now let's change the type of variable again. Now we are talking about, let's imagine that now we're going to talk about age, right? age can have many different values. It can go from 0 to 100 and something. We have cases of, so it could have 100 and something unique values. So if we tabulate, sometimes it might not be as informative. If we tabulate age, we kind of get lost in all these numbers, in all these tables. Sometimes for this type of variables, like age or income or years of schooling even, it might be more informative to summarize, to get just the mean and the standard deviation, and to get this information like what we were looking at before by percentiles, or to get the median. So what we are going to do in that case is to use another command. Rather than tabulate and see all the particular categories, we're going to go and summarize the indicator. To tabulate is also important, and we actually use both, because many surveys, in this case it doesn't happen, but in DHS it's the case, so it's important that you know. People that are 95 or above are given a value of age of 95. The values that are greater, like 98 or 99, don't refer to people actually having 98 years of age. 98 refers to the fact that they didn't answer, and 99 is that it's a missing value. No, 98 is that they didn't know, and 99 that it's a missing value, that they didn't answer. So even if you look at the numbers, you're going to have 98 and 99. And if you summarize, without bearing in mind that 98 and 99 should be dropped when computing a mean, you could get actually a bias estimation. So the tabulate is as important as the mean, and also checking the methodological documentations to find out that kind of information. But in general, the summarize can be very useful. And you can just write sum, and Stata is going to do it for you. So we just summarize age, and we get the number of observations, the mean. So in Bhutan, the average age without weighting is almost 27 years of age. The standard deviation, and here we have the minimum and the maximum value. So already this command gives you a lot of information. Now, of course, we would actually, because we're making an estimation here, we should add the weights to get the proper value of what is representative at the national level. And that's what we're doing here. So you see that actually it's not super different, but it's a little bit lower when we do it with weights. Okay, and now imagine that you are trying to, that you want to combine different variables that are cardinal, so like age, or in this case we're going to do age and schooling, so that they have many values, and we actually want to see for each level of schooling, what's the average age. So I want to see, okay, for what's the average age of people that have just 1 year of schooling? What's the average age for people that have 2 years of schooling? For people that have 3, 4, 5 years of schooling? You can also do that using the command tabstat that I was showing you before as an example. So in this case, we write the command tabstat, the two variables that we want to cross, and we tell them that we want to see them. Oh, we're going to do that later, I'm sorry. And we tell them that we're going to do it by age, actually. So first we're doing it by age, then we're going to cross those other two. So now we see what's the minimum, what's the average age for female, the average age for men, the average schooling for women and for men. Tabstat by default shows you the mean. If you wanted to see other statistics like the standard deviation, or if you wanted to see the number of observations, the minimum, the maximum, you could do it, adding it as an option, and we're going to see it in a second. But by default, Tabstat is going to show you the average, the mean. So basically, it's going to show you by these two groups that you have here. It could be region, it could be sex, it could be any categories that you want, the variables that you are adding here before. And here is what I was telling you, that you can actually choose which are the stats that you want to see. Here I'm asking Stata to do it by region. So I'm going to have many more. Instead of having only women and men, I have all the regions here. And I'm telling again that I want to see age and schooling, but I don't want to see just the mean. I want to see the mean, the minimum, the maximum value, and the number of observations. So I have this option of stats to add at the end. So you see I'm seeing for Gaza, what's the average age and the average years of schooling, the minimum value, the maximum value, and how many people with information do I have. Okay? So again, you can kind of tailor these commands for what you're trying to show. Now, I've already mentioned something about conditions and filters, and when we were looking at this example of TabStat before, and how, for example, we can add this filter here that we only want to see this information for people that are above 17, for example. We might not be interested in looking at all the sample, but just at the particular group. So the way we add these filters, we call them filters, it with this adding this if right here before the comma. It has to go before the comma. It can go before or after the bracket with the weight. That doesn't matter. But it has to go before the comma. Both the weights and the conditions, the filters, need to go before the commas. So here we are asking this condition that only people that have age above 17 need to be included in these estimations. And we can add many other, you can add many filters at the same time. You could actually add also a top value of age. So you could say that you want people that are between 18 and 25, for example. And in that case, you would need to add an additional filter. Here we are just we are dropping those that are below 17, but we have everyone who is 17 or above. So imagine that we want to put some kind of limit of age. We would come here and say that we want to do it if age is above 17 and age, for example, below 30. So the way that we do it here is to say, we put it here with a symbol of and. Okay? If we want people to be lower or equal than 30, we would just simply add here the equal sign. It's very much like we say lower or equal, so we add this equal sign as well. And that, it's simply, we run it like that. But the word if has to be added just once. No, it's not that we need to add if age is below 17 and if age is above. No, you just add the if when you start placing the conditions. And then you just use the connector and with the symbol and. The symbol for O is this one that I have here. This symbol over here. What did I do? This symbol over here represents O. This vertical bar. So it represents that people should be from region 11 or region 12. Okay, so this is the way that you are going to connect the filters. Now imagine and I want to show you why it's important to keep these filters. Imagine that we do a tabulate of enrollment. We're getting that 76% of the population say that they are enrolled at school. But actually, we see that the population that has replied is not the total sample. It's much lower. So we add the option missing at the end. And we find that actually 65% of the population don't have information for enrollment. And when we actually consider that, only 26% of the population are attending. Now, that includes old people that of course they are not attending. They are past the school age. So we can use filters to only concentrate on school age people. So we could tab enrollment only for people that are, for example, between 6 and 15 years of age. And then we see that actually enrollment for the relevant age group is 98.8%. So that's why filters are important, because we actually need to target particular populations when we only have an applicable population and not the entire sample. So adding the option of missing and adding the filters is going to be very relevant, and you're going to use it when creating your indicators. Okay. Now, I'm going to show you here a little bit about creating indicators, because this is going to be important, and you're going to use it for the MPI indicators. The first type of indicator that you might want to create is just equal to a number. For example, when you're creating the weights for the MPI, you're going to have that the weight for, I don't know, living for water could be 1/6 or 1/3 or 1/20, whatever number you want. And it's going to be the same for each individual or for everyone living in urban areas, and it's going to be different from people that live in rural areas, whatever you decide. But it's going to be a number. In that case, you just you use this line. You generate the variable, you put the name that you want that variable to have. In that case, it's going to be called aux from auxiliary. It could be called weight water, for example. And you put it equal to the number that you're giving it. So, for example, generate weight water equal to 1/6. Or generate weight, I don't know, overcrowding equal to 1/18, whatever you want. It's very simple to create variables like that. The other option would be, for example, when you're running some times of regression and you want to consider experience, many times it's considered that age squared it's a measure of or a proxy of experience. And in the service, you usually have age, but you don't have age squared. So what you do is just multiply. You just need to square that variable. And that's also very simple, basically to create one variable as a combination of others. So it's very simple to do. You just tell Stata to multiply age times age, or to add age times this other indicator, or to subtract, or to divide. Stata can do that very easily. You just write what is the way in which you want to combine the variables very easily. Now, a third way in which you create variables could be that when you are trying to create dummies. Dummies are binary variables that take values 0s and 1s, like the ones that we use for the MPI. Our indicators are all 0s and 1s. 0 for people that are non-deprived, 1 for people that are deprived. So you're actually going to be doing this type of thing. Now, in this type of, what you're actually doing here is telling Stata to create a variable that is going to be called aux3 that has to be equal to 1 if the condition between parentheses is being held. So if this condition is satisfied for that particular individual, the variable aux3 needs to be equal to 1. If this condition doesn't hold, the variable aux3 is going to be equal to 0. So for example, for a person that is 12 years of age, what is going to be the value of aux3? 0. And for someone that is above 15, 1. Is it clear to everyone? Okay. Now you could have done it in a different way. This is a very simple and direct way. Because if you satisfy the condition is 0, it's 1, and if you don't, it's 0. Another way would actually be to create a variable equal to 1. You could write it in a different way. You could say like this. Generate aux3 equal to 1 if age is above 15, and replace aux3 equal to 0 if age is below or equal to 15. That's a different way in which you can do it, and both things should give you the same results. But instead of having to write two different lines, you can do it in just one. But it depends on your personal preferences. You can use either way. It's going to give you the same result. Now, sometimes you want to create the same indicator for all the household members. Imagine that you create an indicator on household size. All the members of the household are going to have the same value. Or if you want to compute what's the minimum age in a household or the maximum age, every member of the household should have the same value for that indicator. So in that case, you're going to tell Stata that you want to compute something by household. And the way you do it is by adding this option at the beginning. Where is it? It's very, I can reach. You add this option of by. Now, the survey, sometimes you sort it by different things. Sometimes you sort it by region because you want to check, you want to browse it by region. And so you don't really know how it's being sorted. But in order to do this, to actually compute stuff by household, you need all the members to be clustered together in the data set. Like in Excel, if you want to compute a mean by region, you need all the observations from the same region to be one next to the other, so you can add a function that is average all these rows. But if they are kind of missing, it's going to be much more complicated. You can still do it, but you need to go identify in each of them. If you sort the households all together by their ID, and you have all the members one after the other, you can very easily tell Stata, okay, go and check the household ID. If the house ID is the same as in the previous observation, group them together and do this command for all the household. If it's different, group it with the following household. So that's what I'm telling them to do here. Sort it by household ID and compute this command that I'm doing here. This command is going to be that I want to compute the maximum age within the household, the minimum age within the household, or the mean age within the household. And I want to create an indicator that it's going to keep that information, that it's going to be the same for all the members. Now, as you can see here, I'm not using the command generate. I'm using egen. And that's the main, and that's a big difference. Here, I am creating variables either equal to numbers or with very simple kinds of combinations that Stata needs to do. But here I'm actually asking Stata to run a function to compute a mean, to compute a minimum value. So when you're asking Stata to create an indicator, that a variable that it needs to be equal to the result of a function that has to be run, then you need to use egen. It's exactly the same. The only difference is that you need to add the letter E at the beginning. If you don't, Stata is going to close with an error. So every time that you have maximum, minimum, mean, or any kind of function that you're asking Stata to do, you have to use the command egen. Okay, this is here we have in the do file a few examples of indicators that are MPI-like, in the sense that are similar indicators to ones that you might be interested in keeping, right? So, for example, we have the first one is overcrowding. So we add the number of female and male, and we divide by the total number of rooms in the households. That is this indicator here. That's the typical definition of overcrowding: number of members in the household divided by numbers of rooms. And then we create an indicator 0 and 1, which is going to be equal to 1 if the condition between parentheses is being satisfied. So if people per room it's above 3, if there are more than 3 people per room, I replace that over 1 equal to 1. If I have less than 3 people per room, or 3 people per room as a limit, that indicator is going to be equal to 0. So the household is deprived if there are more than 3 people per room. Here I have the other way of creating it. This gen over 2 is exactly this. You would get exactly the same indicator, but I'm doing it with more steps. So instead of doing it in just one line, I'm doing it in 2, and then I'm just comparing both so that you see that you get the same thing. I'm not going to do it now because we don't have much time of the session and I want to cover other stuff, but you have it here to play around with it yourselves. Then we have an example for schooling, in which again we are summarizing schooling to have an idea of what this variable is. It's always important to summarize and to tabulate the potential indicators that you are thinking of analyzing. And I'm generating a variable of deprivation in schooling if the individual has less than 5 years of school, right? So if the individual has less than 5 years of school, so that condition between parentheses is going to be fulfilled, it's going to be satisfied. And so the school is going to be equal to 1. If I have 8 years of schooling, what's the value of this school?
0.
Is it clear to everyone or not? Because this is what you're going to be doing starting tomorrow.
Can I ask?
Yes.
The room.
Yes.
Why do we sum up male and female?
Because the definition of overcrowding is total numbers of members in the household divided by numbers of rooms. So you want to see how many people you have per room. Male counts the number of male per household. And female is the total number of women in your household. So when you add men and female, you have the whole household being considered. So it's a way of having household size. And then you divide by the number of rooms available in your household.
If we have household size, we just divide.
Yes, if you had an indicator that it's already household size or total numbers of members, whatever it's called, you just use that one. In the particular case of Bhutan, we didn't have that, so we needed to combine it, to compute it. Yes. Okay. Good. Then, and something to consider is that, as you can see, I'm adding conditions. I'm only consider people to be deprived in schooling if they have less than 5 years of schooling, but they are above 15 years of age. If you're 7, I cannot expect you to have 5 years of schooling. You're 7, unless you are a genius, you're not going to have 5 years of schooling or more, right? So I'm only going to ask people above 15 to have 5 years of schooling. Those that are below that age are not going to have, going to be considered deprived in that indicator. Okay, here we have 2 additional indicators for you to consider to take a look at. Yes.
That second term, if schooling not missing, that's what that means?
Oh, yes, sorry, yes. When you want to say, for example, that if children are 15, exactly 15, you don't use just one equal sign. Instead, you need to use 2, right? So if I wanted to say here that age needs to be equal to 15, exactly 15, I would put it like this, 2 equal signs. Now, when I want to imply different than 15, I can do it in 2 different ways, with an exclamation and an equal, or I don't know how do you say that, the thing that goes above the n in enye.
Not equal to.
That thing. So you can choose, you can use both, and in both cases it means no. So it's opposition. It's like a logical, but I'm telling Stata that if age is different than 15. Yes, exactly. I'm sorry that I didn't mention that. Thank you for. Okay. Okay.
Why like the missing?
Okay, and here you have 2 other indicators. One for assets, and then you have another one before for. Oh no, that's the only one that's left. Assets. So take a look at the indicator of assets, but it's very similar to what we were discussing before.
Sorry, going back to the previous variable, we don't have to specify that we're excluding missings, do we? Won't missings in generating a variable automatically be excluded?
It depends on what you have inside the parentheses. Stata considers missing value to be the highest possible value at all. So if here I was putting the opposite condition, right? So if here I'm asking if schooling is below 5, so if it's up to 4, you're going to get a 1. But if schooling is everything that is 5 or above, it's going to be 0. Above includes missing, because Stata considers missing as being the infinitive, or being the largest number. So I'm telling Stata that if the individual doesn't have information in schooling, I don't want Stata to give him a 0. I don't want to assume that he's non-deprived, unless you want to make that assumption. But yes, thank you for reminding me that, because that's something that is very particular of Stata. You always have to ask Stata to limit to different than missing, and you're going to see that in our coding that we do that all the time. Exactly, that's what we are doing. That's why we are adding this if schooling is different than 0 here, that missing here.
Age is different. Not school.
No, here it's schooling. Because what I'm saying is that if you have missing in schooling, I don't want Stata to assume that you are non-deprived. If you have a missing in schooling, because Stata considers that missing is a very, very, very high number, Stata would consider that you are above that 5 threshold, that you have more than 5. You have a huge number of
In this
education.
command, if age is missing.
Where? Well, you can add it. Yes. You can add it. You could add it at the end. You could have here an age different than missing. Yes. I've already know that in this survey I don't have anyone with age missing. But yes, in general you would add it as well. Yes, sorry, I didn't understand what you were saying. But yes. Here there are other examples of creation of variables, water and assets, so I please ask you to take a look at them. We are actually only going to start working on coding indicators tomorrow, so please take a look at these in the afternoon after we finish today, because it's going to be important. These are good examples for you to know how to do it. Okay, but this should give you an idea of how you can create indicators tomorrow when you start creating indicators for your own MPI measure. There is something that, that exists on Stata and in many other similar programs like SPSS, Sonar, that is called loops. Basically, when you want to repeat the same command several times, for example, I want to compute something for all the regions in the country. So I want to do these few lines of commands for region 1. Then I want to do the same commands for region 2. Then the same lines for region 3. And the same for region 25. I can write the same lines of commands several times, 25, 30 times, and that's perfectly okay. Okay, you're going to get perfect results anyway. But in the interest of saving time and lines of coding, if you want to have a more efficient do file in the sense that you are diminishing the chances or you are reducing the chances of making any mistakes in coding, or you want to have it more concise, you can use what is called a loop. Basically, you just ask Stata to repeat the same lines over a particular group of regions or age groups or genders or whatever groups you want it to run it over. So that's what it's called a group. One very simple type of group would be a household. All the household members belong to a particular group, which is the household. So I could ask Stata to compute the same thing for all the household members. When we were computing before the maximum age at the household or the minimum or the medium age, basically I was computing the medium age in the household for individual 1, considering all the ages in the household. Then I go to the mom and I take at the average of all the ages of the household members. Then I go to the first child and to the second. But for all of them, I'm doing the same, computing mean age. And the way we did it was by using the by household and the EGEN. So I can do that. Now, when I want to go from individual indicators, right? We have, for example, level of schooling at the individual level, people with less than 5 years of schooling. And I want, for example, to take that to the household level, to create a household level indicator of schooling, I can also use the same structure. So I could say, okay, what's the minimum in that variable of schooling at the household level? I have individuals at the household with over 5 years of schooling, so they have a 0, right? Or not? Have I lost you?
Can you repeat again?
Okay. In the variable of schooling that we created before, people that have less than 5 years of schooling have a 1 because they are deprived, right? They were satisfying that condition in parentheses. Yeah? Okay. And then some other members in the household might have a 0. In which case? When are people going to have a 0? Exactly. When they are not deprived because they have over 5 years of schooling or 5 years of schooling. So in the same household, I could have one member that is deprived, the other member that is non-deprived. So I could keep the information at the individual level, or you might need or might want to combine and have a household indicator. Like, for example, we do in the global MPI. It's not required, but it's something that you might want to do. So in that case, you can compute what is the minimum level or the maximum level that that indicator has at the household level. So it depends on what you want to be the deprivation at the household level. You might say a household is deprived if any member in the household is deprived. So if at least one member, if there exists at least one member that hasn't completed 5 years of schooling, the whole household is going to be deprived. So in that case, I'm going to compute the maximum level, right? Because if there is at least one, even if I have a household with 10 members, if 9 of them have 0s because they are non-deprived, but there is one that has a 1, so there is one person that at least is deprived, I want the whole household to be deprived. So I want the maximum level, right? I have 9 zeros, but I have a 1, and I want that one to be the one that is determining the value. I will compute the maximum at the household. The opposite thing would be to say, okay, if there is no one at all, right? So if there is at least one person with education, the whole household is deprived. So if I have the same household with 10 members, and I have 9 people who are deprived now, they have ones, but there is at least one that has a 0, but because he has completed 5 years of schooling, then I'm going to consider the whole household non-deprived. So in that case, I use the minimum. That's the criteria that we use for the global MPI. We consider if there is at least one member in the household that has 5 years of schooling. So again, we use the same kind of structure that we were using before. We use the by household, and we compute the maximal years of schooling, right? But you could have chose to use the minimum year of schooling. And that's the first kind of loop, because you're going to compute that for every member in the household, and they are all going to have the same value in that indicator. This should be, first of all, this should be by, and this is you could write, yes, by sort. Like I was mentioning before, in Stata you don't actually need to write the whole word. You can just summarize it, and instead of writing generate, you can write gen, GE, or just the G, because Stata already knows. I mean, it depends. If you have many other commands that start very similarly, you might not be able to. But Stata, usually when you go to Stata and you write, for example, help generate, in this case I don't have it because I can just write the G. It used to be there. Tabulate. Gen, no. Yes. So you see here that tabulate is underlying TA. So that means that as a minimum, for Stata to know that you are referring to this command, you need to write TA. You don't need to write tabulate. You can write tabul. Doesn't matter. Stata will always know that it's tabulate, but you at least need to write TA. If you write only T, Stata is not going to know which command you're referring to, because there are many similar. Table, tabulate, tabstat. So for tabulate, you need TA. So usually when you go to the help indicators, it's going to underline the minimum that you need to show, to write. Okay, and I'm going to go, because I'm past my time, so I'm going to go very quickly through the most general type of loop that you're going to use. And you see, there are a few things. This is where the do file ends, so I'm almost there. I promise. I promise. Now, like I was saying before, imagine that you have you want to summarize age by region, and I show you how to do it before using tabstat. But then you could also sometimes it's not just a line. Sometimes you want to do many things. You want to summarize age by region, and then you want to create a variable that keeps that mean, for example, and then you want to do some few other things, right? And you want to do it for region number 11, then for region number 12, for region 13, and 14, and 15. So one way to do it is to put things between, ¿cómo se dice llave en inglés? Key? Sí. No, because it's not bracket. It's the other brackets. Curly brackets? Okay. The curly brackets. The nice brackets. Okay, so you can just put things between the curly brackets, and Stata will reproduce whatever is in those curly brackets in a loop, like as a sequential series. So how is that usually written? Here I'm telling Stata that for all the variables, right, that I'm mentioning here, so for toilet, for cooking, for electricity, and for cooking fuel, this is the way you would write it. For each bar in, and you put the list of variables. That list of variables could be like this, or you can put it between quotations. But it's not needed. So you choose. But I'm just telling Stata, for each one of those three that I have there, toilet, electricity, and cooking fuel, I want you to do this. I want you to generate a variable that it's going to be called W under dash and something else that I'm going to talk to in a second, equal to 1/4. That something else that comes after the under dash is going to be replaced by the name of each variable. So here I'm going to replace this bar by toilet. So I'm going to create W under dash toilet equal to 1/4. Then I'm going to create W under dash electricity equal to 1/4. And W under dash cooking fuel equal to 1/4. So basically this thing here, bar, is what we call a local in Stata. And it's going to be replaced because I'm telling Stata that actually each var that appears in the coding needs to be replaced for that series of variables, but that var list that I have given Stata. So it's going to be replacing them, and we're going to generate 3 variables. So, for example, if I take this to Stata, essential, you need to remember to close the curly one, or it doesn't run. So now, if I ask Stata to describe, you see, Stata has created W toilet, W electricity, and W cooking fuel with just one line. In this case, actually we have 3 lines for 3 things that Stata has done, but usually it's much more useful and much more efficient when we have many things that are following inside those curly brackets. Because imagine if you have, I don't know, 50 lines of coding that you need to do for each of these 3 variables. If you need to repeat those 50 lines of coding each time, it will consume a lot of time. And there are a lot of chances for you to actually forget something or make a mistake in the coding, and then Stata stops and you have to go back and see what's wrong, and that's very frustrating. So if you get it right once, and then you can state Stata just to repeat it twice more, then it's much easier and much faster and much more efficient for the software to do. So you're going to be using this, sorry?
Also easier to read that.
Well, for me, for example, it's much easier to read it directly like that than to read very long lines of commands. Some people prefer, instead of using all these symbols and stuff, to actually have the lines repeated many times. And again, if you like to do it that way, it's perfectly fine. You're going to get the same results. But it's something to know that it's an option. And something else is that, and this is another example, because here I'm telling it that it should do it for variables. And you're going to see when we share with you the do file that we used to create the Alcayer-Foster, the MPI, that we use this for each many times. Now, for example, for compute the sensor and sensor head counts, we don't repeat the code for the 10 indicators of the global MPI. We actually have it in a loop, so that for the 10 indicators, we compute the unsensor head count for all of them in the same way, right? Now, the other type of loop that is very useful, and I promise that with this I finish, is to use for values rather than for each. Because if I want to do something for many regions, like I was saying before, what is going to change is not the variable. The variable is always going to be region. I'm always going to be doing it for region. But I'm going to be doing it for different values of the variable region. For region equal to 11, 12, 13, and so on. So what I'm going to tell Stata is that for values that go, for example, from 11 to 15, I want Stata to do a particular thing if region is equal to that particular value. So again, I put everything between curly brackets, and Stata is going to repeat it for the different values that I'm giving it. In the example that we have here, we are telling Stata that I want to go for values 10 to 50. 10 to 50 by increments of 10. If I don't put anything here, so the other option would be, no.
11.
The other option would be to have it like this, with a diagonal bar. If I put it like this, Stata is going to go 10, 11, 12, 13, 14, 15 until 50. But if I'm interested in increments of 10, like this, Stata is going to go 10, 20, 30, 40, 50, and it stops. So I'm telling them that for values that start in 10, finish in 50 with increments of 10, I want Stata to generate variables that are going to be called new var 10, new var 20, new var 30, new var 40, and new var 50 equal to that value of x. So new var 10 is going to be equal to what? If I start with the first value, right? For value x equal to 10, generate new var 10 equal to 10. Exactly. So it's a very simple line of coding, right? Here we were just giving a very simple example. But you could have something generate new var equal to x if region equal to x. So if region is equal to 10, I'm doing this. If the region is different, I'm not doing it. Okay? Now, please take a look at these two files. If you have any questions, you can send me an email or we can talk about it. You can look at it today if you have time. I'm assuming that with our schedule, you usually are not going to have time to do other stuff. You need to be paying a lot of attention. So you're not going to be actually doing this during the sessions, but we can discuss it tomorrow or today or whenever you feel like it. This is just an introduction, and this is going to be a good base for us moving forward when we start working. But just for those that have never touched data before, it's not that we're going to just drop the surveys on you and tell you, okay, go ahead and compute. We actually give you a very detailed do file, and you just need to adjust it. So it comes with 4 indicators that have already been created, and you can keep them, or you can adjust it, and you can add more, and you need to adjust a few tweaks here and there, and we are here the entire time that you're working, okay? And you can ask us anytime, anything you need. We are here, so, okay, yes?
Last one, 5th point, survey set.
What? Below, yes. This is for complex surveys. I don't know, Paola, if you want to discuss it a bit more, but when you are trying to make estimations, it's really important what's the type of survey design that you have and what was the stratification and, well, the whole design that was taken when creating the sample. Basically, with this, you are letting Stata know which are the survey details. So you are basically letting it know which is the primary sampling unit and which is the strata variable that are usually contained within the database. So you have already a variable there that is called strata, and you have a variable that is called PSU. So I'm just letting Stata know that the sampling design was done following those variables. And then when I'm computing, for example, a mean, if I want to have the most accurate estimation of the mean of this school, for example, I'm actually going to tell Stata to take into consideration the design of the sample. And something to bear in mind is that this is something that is relevant, especially when you are estimating stuff. Now, when you are in the stage of creating indicators, this is not something that is going to affect the creation of indicators, right? But when you are starting to estimate stuff, it's something important. You can just drop this line at the very beginning of the do file, so it's already there and you don't forget. But it's essential that you do have it when you're working with complex surveys, at least when you are actually starting to estimate stuff, when you're starting to get stuff out. Okay, okay, so now,
One more.
okay, can we talk offline so that the rest can go to coffee break?
Yeah, just one.
He doesn't, it's his fault, he doesn't want to let you go.
No, just there is also we can use something called local and global.
Yes.
Like, rather than mentioning so many variables,
Yes.
once you mention the global and local, if you can throw some light, it will be helpful.
Yes. Well, actually, locals we were already using for the loops. A local and a globals are scalars or variables that you are using, but you are not actually generating or creating in the data set. So, for example, imagine that you want to use. Imagine, for example, that you compute what's the mean age in the population, and you want to keep that value. You want to use the mean for later analysis. So you store the mean, you store that value into what we call a local. And so then you can call that local, you can call that value anytime you need to use that mean, anytime you need to use that value. But when the do file stops, either because it breaks for an error or because you finish, or when you close Stata, that local disappears. It's not a variable that you have created in the data set. So for example, you would do it something like this. You would summarize age. Imagine that let's do it properly. summarize age, AW, weight, and so I'm saying local, and it can be called mean, equal to R mean. Summarize is a command that it is said that it's an R class command, in the sense that the R means that you can return results from that command. When I estimate this, when I summarize a variable and I get the mean, the number of observations, the standard deviation, minimum and maximum, I can ask Stata to give me back those values, not only to show them in a table, but actually to bring them back to me so that I can store them or that I can play with those numbers. And the way that you tell Stata that you want those numbers back is by using this. R, and between parentheses you put what do you want to keep. The mean, SD is the standard deviation, the capital N is the number of observation, mean or maximum. Now in this case, I'm creating a local that is going to be called mean equal to the mean that I got from summarizing age. Now, if I want to use that mean later on, for example, if I want to see it on screen, I would write display mean. But if I do mean like this, Stata is going to look for a variable that it's called mean, and there is no variable. There is only a local called mean. So I have to indicate to Stata that it's a local and not a variable. And the way to do it is with these weird symbols that I have here around the X. So I have first like a, how do you call these things in English? Like the kind of weird accent to the other side. And here the apostrophes. Okay, that thing there, you can see it. Kind of diagonal in the weird place and the one that is straight. Right? This is how you call a local. Now Stata is going to know that it has to display a local that is called mean. Again, if you don't put these symbols, Stata is going to look for a variable called mean in the data set, and it's going to say error. There is no variable called mean. So it's important to use those symbols, and that's why I was using them up there for the X. Now, as I was saying, if the do file stops because it breaks, because I stop it, or because it finishes, the local disappears. Now, sometimes another option is to create what is called a global. A global is also not a variable, but it's something that even if the do file stops, it's going to still remain existing there in the do file until I close, it's going to still exist on Stata until I close Stata. So even if the do file has stopped, I can still call the global until I close Stata. And the way you do it here is that instead of writing this, it's the same. I would just write global. And the way I would ask Stata to show it to me, rather than with these symbols, is with a money sign. This is how you call for globals. So this is also something very useful. You are not going to find globals in the do files that we are going to be sharing with you, but you're going to see many locals appearing all around. So it's good that you know how to use them. Okay? Good.